welcome you. You have a little idea about the molecular symmetry, and you have studied a little thing about group theory in your BSc final year class, I think. Today, I am discussing here, it's in your first chapter, molecular symmetry group and the matrices. So, when you are studying symmetry, you know that symmetry is there for in the universe or in. So here you are studying the symmetry. The symmetry property of a molecule can be used to predict a vibrational spectra, hybridization, and of course optical activity of a molecule. So you will study even vibrational in the sense Raman active, IR active. We'll have more discussion in the next chapter. So let me tell you, this is a very important and very complicated topic, and normally students face little difficult, but I will try with my best to give you a good concept as simple as possible. You have to follow me in a very systematic manner. I will give the videos, and of course you will have examination very soon, maybe in the next month or 1.5 months later. So I will have somewhat quick for completion of the portion. So I hope you will be very serious about the videos I am uploading. Okay, so these three objects, whether they are symmetric, of course you know that this is symmetric, this is not symmetric, and this stone is also not symmetric. Why? How you say that it is symmetric or not? You just rotate it. That is, symmetry in an object or in a molecule can be determined by this is a following operation. We can say that rotation. Broadly, this can be said that rotation and reflection. Okay, so you can say that this is not, after rotation, this is not a symmetric. Because what do you mean by symmetry operation? An operation is carried out in an object in a molecule so that initial and final position are not distinguishable. Okay, so they are distinguishable, so that this is not a symmetry operation, and this is also not a reflection. This is also not symmetry. So your one hand is not symmetric with the other hand. The one hand is you can say the mirror object of your other hand. So after reflection, you can say there seems to be mirror images to each other. This field, one hand, this is another hand. This is not same hand. So all the reflection also, this is not showing any symmetry, so that you can say that the hand is not asymmetric, or this is asymmetric. Okay, object. So by definition, you can say that symmetry is defined in terms of element and operation. Elements are axis or a plane or a point, an imaginary line, or imaginary point about which a symmetry operation is carried out. Operation means it may be reflection, rotation, or inversion. It may be reflection, rotation, or inversion. Okay. So An operation is symmetric if the resulting object is identical to original. So they are not distinguishable. So that is called operation. Operation is an symmetry operation is then operation carried out with an imaginary axis or imaginary point or imaginary plane. I hope you are getting it, because you have already studied these things, but I am just refreshing your learning. So symmetry element, or it may be a mirror plane or axis of rotation or center of inversion. The molecule has a given symmetry element if the operation leaves the molecule appearing as it is, nothing has been changed, even though atoms or so by doing a rotation, atom has changed from one point to another point. But it seems that is when some operation is carried out when your eye is closed, and I am asking you whether operation is done or not. They are not distinguished because the identical are seen. For example, water molecule is rotating about 180 degree. So you can say that that is an symmetry operation. So element, you can say that symmetry element rotation by Cn. So it is represented by Cn. Identity is E. Means we'll discuss later identity. What is identity? Anyhow, you know the identity, what you mean by. And rotation Cn, it means if it is rotated by 2 pi by n. Okay, so that is theta is 2 pi by n. So you can find out the n value based on this. For you can 2 pi by theta gives the n value. Okay, means if n is 1, means rotation is about 360 degree. Every object, when you rotate 360 degree, it appears nothing has been changed. When you rotate an object 360 degree, so you can say that that is a symmetry operation. All object has the symmetry operation of C1. Okay, we'll discuss. And for example, a rotation about 180 degree. So it gives the same appearance. Okay, it gives the same appearance. For example, when I rotate this about, suppose this is plane. Okay, this about 180 degree, it appears to be same. That is an object that is they have the C2 axis. Okay, you can say that they have a C2 axis. And reflection is denoted by sigma, and inversion is denoted by I. And there is one more reflection followed by rotation, that can be also Sn. So there is an improper axis of rotation. So these improper axis of rotation and inversion are also this can be also get from these two operation, that is reflection and rotation. So I have in the first slide I told you that the symmetry operation can be determined with the help of reflection and rotation. So first thing, n-fold rotation. N-fold rotation. Water has a two-fold axis of rotation. Water has two-fold axis of rotation. When it is rotated by 180 degree, so when it rotates by 180 degree, so what happened? This 180 degree hydrogen, this is hydrogen atom, and this hydrogen will be replaced by this. That is, you can say that H1, H2 will be interchanged their position, but it seems to be same. So exactly same. That is why water molecule has the C2 axis. You can say that they have the C2 axis, two-fold axis of rotation. Okay, so similarly, ammonia molecule. This is an ammonia molecule, nitrogen and 3 hydrogens. Okay, so when you rotate it by what degree? When it is rotated by 120 degree, so what happen? This position will be it is, and next rotation, that is C3. C3 means what is the degree of rotation? You divide by 2 pi by 3. C3 means 3. Okay, that is 120 degree. Or in other words, so when you gives the rotation, you can find out the rotation. If you know the theta, you can find out the what is the fold axis n. Okay, if you know the theta, you can find out the n. In other words, if you know the n, you can find out the theta. Okay, that is 2 pi by theta is n, or theta is equal to 2 pi by n. So this is a symmetry operation. This seems to be same. Okay, but you have done the operation. Okay, C3 square. This can be sent. You do C3 again. You do C3. That is H1, H2, H3. Suppose. Okay, the H1's position will be here. H2's position. In this case, suppose this is H1. Then you rotate 120 degree. What will happen? H1 will be here. Okay, so again, when you do again one more degree rotation, what happened? H1 will be here. Okay, suppose this is H1, so you can see 3 square. Okay, C3 square. When you do again the rotation, okay, so that is called C3 square. So we'll discuss more. So what is the principal axis of rotation? If a molecule possesses more than one type of n axis, the axis of highest value of n is called the principal axis, and it is the axis of highest molecular symmetry. For example, BF3 molecule. BF3 molecule. What is this? So BF3 molecule. You know what is the geometry of the BF3? It's a trigonal planar molecule. Okay, trigonal planar molecule. So what is they have C3 is there, C2 is also there. Okay, so when you take the BF3 molecule, I think you know BF3 molecule shape. So they have a C2 axis is there. Okay, you have one assignment, or you have to draw the C2 axis of BF3 molecule, and also you have to draw the C3 axis of BF3 molecule. Okay, so BF3 molecules, there are C2 axis, C1 axis is also there. Every molecule has C1 axis, because 360 degree rotation gives the same appearance, so it is C1. C1 is there, C2 is there, C3 is there. So in that highest axis of rotation is C3. So that is why this principal axis is C3. Okay, principal axis is this is a very important definition. You may ask in the 1 mark question set. So that is all about the C3, n-fold axis of symmetry. Next is plane, mirror plane. So what do you mean by mirror plane? So it is the reflection of molecule gives the reflection of, so you can see that reflection means it seems that can, this molecule can be divided into, molecules can be divided, or this molecule is seems to be a mirror plane, that is at the middle there is a mirror, is because they can be cut into two equal halves, such they are called they possess a plane of symmetry. Okay, the resulting molecules they have the plane of symmetry. Okay, so you can say that sigma v, plane of symmetry can be represented by sigma v, and okay, I will give you one PDF so that you read from there also. Okay, so I will attach with this video, don't worry. So sorry for inconvenience was during my presentation. So it is called mirror plane. Okay, so there are sigma v, sigma d, and sigma h. Okay, so you can say that when plane of symmetry is passes through the principal axis, they are called sigma v. Okay, when it is passes through the principal axis, it is called sigma v. Okay, so this is sigma v. Then two sigma v's are there for water molecules. So we can say that. And but the water molecules, there the and benzene, for example, benzene here you see here. So sigma h means all planar molecules has this sigma h. Okay, and horizontal plane, so horizontal plane of symmetry. And sigma d means when they bisect the angle. Okay, so you can, this is a carbon and this is also carbon, this is its center, and if it is bisects their angle, then are called sigma d. Okay, and if the plane is passed through the principal axis, they are called sigma v. And sigma h molecule passes the plane of symmetry, that is called sigma h. So three type of mirror planes are there. Okay, so you can say that sigma vertical plane go through the C6 axis, and dihedral angle, the bisects the bond, or bisect the bond, or bisect the bond, the angle, they are called dihedral plane. Okay, next symmetry operation is inversion. Okay, inversion. What do you mean by inversion? Inversion is an operation project each atom through the center of inversion across the one side of the molecule. So that is, invert means molecule is inverted. Okay, so you see here this molecule has the 6 atom attached at the center molecule. Okay, and center of atom, and it is inverted, that is the S, this is inverted. So you can say that all its atom position is changed. Okay, all its atom is changed. So you see here 2, 4. Okay, 2 is changed to 4, and 3 is changed to 5, and 1 is changed to 6. So this is called inversion. Okay, so and the next is improper rotation. I think you have little idea about the improper rotation also. Improper rotation means a molecule has carried out two operations simultaneously. Two operations simultaneously. That is rotation followed by reflection, or reflection followed by rotation. That is, you can that Sn is the Cn into sigma, Cn into sigma. Okay, so you can say that here you see this molecule is rotated, okay, rotated about 90 degree, about 90 degree. What happened? D here, D will 90 degree means appears in this position, right? And the C will go here, and this will come here like that, and B is, but this is not a symmetry operation. This is not a symmetry operation. This is different, but it is reflected perpendicular to its rotation axis. It is giving a symmetry operation. So it is, you can say that S3, sorry, S4. Okay, S4. This is an S4. So an improper rotation is followed by a reflection perpendicular to the axis of rotation. It is called improper rotation. Let me tell you one thing here also. Inversion is a rotation followed by reflection. It is C2 rotation and a reflection. Actually, inversion is a kind of you can say that I is equal to C2 into sigma h. I is equal to C2 into sigma h. So you do C2, okay, C2. What will happen about this? 5 will appear here, and then you reflect and followed by reflection perpendicular to the. So it is the that is improper rotation. Okay, so this is this you can say that the, for example, for a staggered conformation of ethane has the S6. Okay, how you do rotation about 30 degree. You do rotation about 30 degree. Sorry, 60 degree. Okay, so what will happen? Ethane molecule in their staggered position. So when you do, so C6 rotation means what? How much degree? 360 divided by 6, that is 360 divided by 60 degree, right? Okay, so you can say that ethane molecule in their staggered, they have the S6, okay, and followed by reflection is a symmetry operation. So what is the S1 means? What is the S1 means? One more thing, I told you S2 is inversion. And what is the S1? S1, you do one, means you see here, you do rotation about the 360 degree, means same, but on reflection perpendicular to that rotation means gives symmetry operation, that is actually sigma. Mirror plane is also an improper rotation. So simply this is all about the improper rotation. Okay, so inversion is, it is explained here. Inversion is a S2, okay, S2, and last one, identity. What is the identity element? A molecules have identity means the all entire molecules appears to be same. They are called, they have the identity. Okay, so let me take you. So sorry for a delay, some technical problem actually. So you see here, okay, I'm giving you this PDF, okay, and you have to go through it. So identity operation E appears on we can say that identity, if Cn raised to n is an identity operation, that is C2 square is an identity operation, C3 square is an identity operation, and sigma square is an identity operation, and the I square is an identity operation. And one important thing, it is the and you can say that if you note down this point also, if the Sn, if a molecule is Sn, and if n is even, you can say that S raised to 2n is an identity operation, and if n is odd, okay, and n is odd, the S raised to n is an, sorry, as n is odd, S raised to 2n is an identity operation, and if n is even, the S raised to n is an identity operator. That is, for example, C3, S3 is there, S3 is there, then S3 raised to 3. What is S3 raised to 2 means what? S, you do S again, S3 again S3, then it is S3 square, then S3 cube. S3 cube is not an identity operation, but S3 raised to 2n, that is S raised to 6 is, S3 raised to 6 is an identity operation. But S raised n, in the case of the rotation, Cn, n raised Cn square, C2, then C2 square is an identity operation. C3, for example, C3 is there, C3 square is not an identity operation. C3 raised to cube is an identity operation. That is C3 again C3. Okay, so I am stopping my today's lecture. You have to go through this PDF and you have to make a note on this same PDF up to point group. So in the next chapter, in the next identity of you go through this and you make a good note about whatever the things I have already teach you, okay, up to a point group in this PDF. Okay, so you have to read carefully. There are many examples. I will show some more uh, uh, software which gives the which illustrate the symmetry point group in the symmetry element in the next video. Okay, so I'm really sorry for some inconvenience while I record this lecture. So I think everything will be clear in the next class onwards. So thank you for your patient listening.